Hi, magandang araw. Karamihan naman siguro sa atin ay familiar na or nasubukan ng makagawa ng iba't ibang klase ng mga projects like robotics, automation, and other electronics or mechatronics projects using this board, the Arduino board. O kaya naman itong Pinoy version ng Arduino board, which is yung Arduino board. Alam nyo ba na pwede pa nating mas paliitin yung mga projects natin using only this ATmega328P IC or yung mismong microcontroller or yung heart ng mga Arduino boards? At sa video na ito, ipapakita ko yung basic kung paano ba tayo makakapag-program ng ATmega328P microcontroller at paano ba natin to gagamitin sa iba't ibang klase ng mga projects natin. So, simulan na natin. So, ang ATmega328P is a microcontroller chip produced by Atmel Corporation, now Microchip Technology. It is available in both dual inline package and surface mount package. The ATmega328P is an 8-bit ABR microcontroller that has 32 kilobytes of flash memory, 2 kilobytes of internal SRAM or static random access memory, and 1 kilobytes of EEPROM or electrically erasable programmable read-only memory. The ATmega328P deep or dual inline package version has 28 pins in total. It has 6 analog input-output pins since mayroon itong 6 na channels ng 10-bit ADC or analog to digital converter. It also has 14 digital input-output pins, of which 6 can be used as PWM outputs. ATmega328P operates at 1.8 volts to 5.5 volts, but normally we use 5 volts as the standard. So it has 2 master and slave SPI or serial peripheral interface, 1 programmable serial, universal synchronous and asynchronous receiver transmitter, and also it has an I2C interface. So ang ATmega328P ay isa sa mga ABR microcontrollers na ginagamit ng mga Arduino and Arduino boards. So bago tayo mag-start mag-program nito, tignan muna natin saglit yung purpose at functions ng bawat pins nito. So start tayo dito sa upper left pin, which is si pin 1. So, pin 1 is used as the reset pin. If we apply a low voltage signal dito or i-connect natin siya sa ground ng circuit, which is 0 volts, it will reset its program. Equivalent lang siya ng kapag pinindot natin yung reset button ng Arduino board. Then, pin 2. Ito yung digital pin 0 or D0 natin pag nakalagay sa Arduino board. Ito din yung RX pin or yung receiving pin for serial communication ng chip. Next, pin 3. Ito naman yung digital pin 1 or yung D1 natin sa Arduino Uno board. Also, ito ay ginagamit as TX or transmitting pin for serial communication. So, si pin 2 and pin 3 yung mga pins na ginagamit kay Arduino or ATmega328P for serial communication interface. For example, pag nag-upload tayo ng code using USB connection from the computer to the Arduino boards. So kaya hindi advisable na may ibang device na nakakonect sa dalawang pins na to pag nag-upload tayo ng program or sketch if we are using USB serial communication. Next is pin 4, pin 5, and pin 6. So these pins are also digital input-output pins. But si pin 5 is capable for PWM output pins or yung tinatawag na pulse width modulation. Ginagamit ito for example if you want to control the speed of a DC motor using microcontroller or controlling the brightness of LED. So PWM pins ang capable sa mga ganitong klase ng application. Then pin 7. So pin 7 is the BCC or dito kinokonek yung positive ng power supply natin for powering the ATmega328P. And pin 8 naman is yung ground. So dito naman kinokonek yung negative or ground ng power supply natin. Then, yung pin 9 and 10 naman are dedicated for external clock. So dito natin nilalagay yung crystal oscillator to provide external clock pulse to the chip. And then itong mga pins from pin 11 to pin 14 and from 15 to pin 19. So lahat yan ay mga digital input output pins. But si pin 11, 12, 15, 16, and pin 17 are also PWM pins. And yung pin 16, 17, 18, and pin 19 naman ay yung mga pins na ginagamit when using SPI interface. So tandaan natin itong mga pins na to kasi another way ng pag-program maliban sa via USB serial communication, which is using the RX and TX pins, ay pwede din mag-program ng mga microcontrollers using these pins, which is via SPI. So pin 16 is for SS or slave select input. Pin 17 is the MOSI pin or master output slave input. Pin 18 is MISO or master input slave output pin. And pin 19 is the ECK or yung bus serial clock pin when using SPI connection. And also, pag gagamit tayo ng mga modules na naka-SPI interface, like example na lang yung SD card module. So dito sa mga pins na to, i-connect yung module. The next, pin 20 is also BCC, but for powering the ADC or yung analog to digital converter ng ATmega328P. Then pin 21 naman is the analog reference voltage or yung RF. So also for ADC ng chip. And si pin 22 is also ground pin. Then from pin 23 to pin 28, so these pins are all analog input pins. So ito na yung 6 analog pins ng ATmega328P. So kadalasan ginagamit ang mga ito sa mga analog sensors natin. So sa Arduino Uno, ito na yung A0 to A5 ng board. But also, si pin 27 ay yung SDA or Serial Bus Data Input-Output Line when using I2C interface sa ATmega328P. And also, si pin 28 naman yung SCL pin or yung Serial Bus Clock Line when using I2C connection. So for example, gagamit tayo ng RTC module with ATmega328P via I2C interface. So sa pin 27 and 28 natin, i-connect yung SDA at ECL ng module natin. So now, alam na natin yung trabaho ng bawat pins ng ATmega328P. So pwede na nating simulang mag-program at gumawa ng simpleng project lang gamit ito. But of course, kailangan natin ng additional passive components para sa circuit ng standalone ATmega328P microcontroller. And siyempre, software at driver na gagamitin para makapag-program nito. So, maraming methods ang pwedeng gamitin para makapag-upload tayo ng program or sketch natin sa ATmega328P. Pwede tayong gumamit ng another microcontroller boards like Arduino boards to program ATmega328P on a breadboard. O kaya naman, using USPasp at iba pang mga programmer boards. And sa video na ito, ituturo ko yung ilan sa mga way natin na pwedeng gamitin para mag-program ng standalone ATmega328P or yung mismong microcontroller chip na hindi nakalagay sa Arduino or Arduino board. So, simulan na natin. So, dito sa unang way na ituturo ko, gagamit tayo ng USBasp clone from Gizmo to program our ATmega328P via SPI or Serial Peripheral Interface. So take note lang, meron tayong dalawang klase ng interface para makapag-load ng code sa mga microcontroller. First is using the USB serial communication, which is yung via RX and TX pins. And second, using SPI or Serial Peripheral Interface, which is yung via MOSI, MISO, SCK, and SS pins. Okay? So mag-start tayo sa hardware part. So ito yung mga components na kakailanganin natin para sa circuit ng microcontroller. So una, ATmega328P yung bootloaded na. So hindi natin kaagad ma-uploadan ng program or sketch yung ATmega328P if wala pa itong bootloader. But since nanggaling itong ATmega na ito sa Gizmo Mechatronics Central, it is already bootloaded na. So hindi na natin kailangang mag-bootload pa. Then, breadboard para paglagyan ng circuit. Dalawang 22 picofarad ceramic capacitor, isang 16 MHz crystal oscillator, isang LED as for testing lang para makita natin na working yung microcontroller, isang 10 kilo ohms na resistor, at isang 100 or 330 ohms na resistor para lang sa LED natin. Jumper wires. So need natin ng male-male jumper wires to connect our circuit, and also male-female wires para ma-connect natin yung USBasp pins sa breadboard. Then, isang 10 microfarad electrolytic capacitor. So optional lang naman ito, but mas maganda if meron tayo nito sa circuit. Then of course, USBasp clone from Gizmo, or any USBasp board will work the same. So ito yung circuit diagram to have a standalone ATmega328P microcontroller. And kung nalilito kayo kung saan yung mga pins respectively sa ATmega328P IC, kung titignan natin ng maigi, meron siyang parang half moon shape. So yun yung top ng IC. So una, ilagay natin ang ATmega328P microcontroller sa breadboard. So dito ko siya ilalagay sa pagitan ng divider to make sure na separated lahat ng pins nito, bawat row. Then, maglagay tayo ng wires to connect the VCC and ground ng chip sa power rail ng breadboard. So maging aware tayo sa connection para maiwasang masira yung microcontroller. So pin 7 and pin 20 connected sa positive rail using red wires. Then pin 8 and pin 22 naman connected sa ground using black wires. So next, maglagay tayo ng 10 kilo ohms na resistor from pin 1 or yung reset pin to the positive line ng circuit. So ang purpose nito is para maiwasan lang na mag-reset yung ATmega natin. Since connected siya sa positive, so equivalent ito ng high signal. Nabanggit ko nga kanina na pag nag-apply tayo dito ng low pulse signal, ay magre-reset yung microcontroller natin. So kaya natin siya kinonect sa positive line. So next, ilagay natin yung crystal oscillator natin sa pin 9 and 10 ng chip. So kahit magbaliktad lang yung paglagay since wala itong polarity. Then, at the same row ng pin 9, ilagay naman natin yung isang paan ng 22 picofarad ceramic capacitor. Then sa ground rail naman yung kabilang paan nito. Ganon din sa pin 10 ng ATmega, maglagay tayo ng isang 22 picofarad ceramic capacitor. Then sa ground rail din yung kabilang paan nito. So kahit magbaliktad lang yung paglagay niyan since non-polarized din ang ceramic capacitor. Then, maglagay tayo ng 10 microfarad electrolytic capacitor across the power lines ng breadboard natin. So yung may gray na strip is yun yung nasa ground rail natin i-connect. Then, ilagay natin yung anode ng LED sa pin 19. But of course, maglagay tayo ng current limiter na 100 or pwede na ring 330 ohms resistor sa LED anode para maiwasang masira yung LED. Then yung cathode naman, i-connect natin dito sa ground. Okay? So now, buo na yung circuit ng standalone ATmega328P on a breadboard. So proceed naman tayo sa software at driver na kakailanganin natin. So sa software side, need natin ang Arduino IDE, which is kung saan tayo magsusulat ng code or sketch na i-upload natin sa chip, and USBasp driver. If wala pa kayong Arduino IDE, so mag-install muna tayo. To install the IDE, punta lang tayo sa arduino.cc, then downloads. So mas prepared ko yung version 1.6.9 ng IDE. lalo na if gumagamit tayo ng Arduino board aside sa Arduino board. So click download the previous version of the current release. Then find and download the version 1.6.9 of the IDE. Then after that, install it to your computer. After installing, i-plug natin sa USB port ng computer yung USBasp module natin. Then go to Device Manager, then Other Devices. If may warning sign yung USBasp, so meaning wala pa itong naka-install na driver. To install that, una, i-download natin yung USBasp driver. So punta tayo sa site ng Egismo. Then search USBasp. Sa baba ng description, i-download natin yung drivers and firmwares. Or pwede ding i-download all para kasama pati yung manual ng module. After downloading, i-extract natin yung file. Then, we can now install the driver by going to Device Manager, right-click USBasp, then Update Driver, and browse the USBasp driver in our downloaded file from Egismo. But wait, if your operating system is Windows 10 or 8, you will get an error message like this. So we have to disable first the signature checking in Windows 8 or Windows 10 before installing the USBasp driver. So sundan lang natin itong procedure na to. First, hold the shift key and restart your computer by clicking the restart button. Then, your computer will restart with some option on your screen. Simply click Troubleshoot, then Advanced Options, then click Startup Settings, then click Restart button. Then after your computer reboots, it will show some option. Then as you can see, the disabling driver signature enforcement is at number 7 option. So simply press the number 7 on your computer keyboard. And your computer will start normally but with disabled driver signature detection. So now, pwede na nating i-install yung USBasp driver. So again, go to Device Manager, right-click the USBasp, and then click Update Driver. And then browse the driver file in the USBasp clone folder and install it by clicking Next button. So now, as you can see, the USBasp driver is successfully installed. So now, naka-install na yung mga software na needed natin. I-connect na natin ang USBasp clone dito sa chip via SPI using these male-female jumper wires. So, ilagay natin itong wires dito sa ICSP programming port para ma-connect natin ito doon sa SPI pins ng ATmega328P. So, sa case na to, okay lang kahit anong kulay ng wires, basta wag lang tayo malilito sa connection. So, itong 6 na pins lang ng ICSP port yung kakailanganin natin. So, una, yung ground pin ng ICSP port ng USBasp, i-connect natin ito sa ground ng circuit. Then, connect the plus 5 volts ng USBasp to the VCC or positive terminal ng circuit. Next, i-connect naman natin itong MUSI pin ng USBasp sa pin 17, which is yung MUSI pin naman ng ATmega328P. And yung MISO pin ng USBasp, connect to pin 18, which is also MISO pin ng chip. The next, yung SCK pin ng USBasp, i-connect naman natin ito sa SCK of the chip, which is nasa pin 19. And last, yung SSP ng USB ASP port, i-connect naman natin ito sa pin 1 or yung reset pin ng microcontroller. Okay, that's it. Now, i-plug natin yung USB ASP programmer sa USB port ng computer and then open the Arduino IDE. Go to File, then Examples, then Basics, and open the Blink sketch. Then, at that sketch, go to Tools, and set the programmer to USB ASP. Now, go to Sketch tab and click Upload using Programmer. So, hintayin lang natin hanggang sa mag-notify na yung IDE ng done uploading. So now, as you can see, the LED at pin 19 is blinking. So subukan nating baguhin yung delay ng pag-blink ng LED. Then, upload it again using programmer. So yan, kung makikita nyo, nagbago din yung bilis ng pag-blink ng LED. So meaning, working yung method natin. Nakapag-program tayo ng microcontroller at ATmega328P using only this USB ASP clone. So next, subukan naman natin gumamit ng Arduino Uno board to flash program on a standalone ATmega328P via SPI interface. So sa same circuit ng ATmega kanina, alisin lang natin yung USB ASP. Ilib lang natin yung circuit ng ATmega328P sa breadboard. So halos same lang yung process from our previous method. Except, before natin i-connect yung SPI pins ng Arduino Uno board sa SPI pins ng ATmega328P, kailangan muna nating mag-flash ng Arduino ISP firmware dito sa board para magamit natin siyang programmer. So para gawin yon, i-connect natin si Arduino Uno sa computer using USB cable. If hindi ma-recognize ng computer nyo yung serial port ng board, then mag-install muna tayo ng CH340 USB to serial driver. So simply search the CH340 USB driver, download it, then extract the file. Then open the folder, then run the setup and click install. So, ang purpose lang nito is para ma-establish yung serial communication between our computer to our microcontroller. So, after installing the driver, tignan natin sa device manager if anong communication port number ng board natin. Then, magbukas tayo ng Arduino IDE, go to Files, Examples, and open the Arduino ISP sketch. Before uploading the sketch, go to Tools. Then, iset natin yung board as Arduino/Genuino Uno. Then, select the COM port number ng board. And then, simply click Upload. And, hintayin natin hanggang mag-notify na ng done uploading. So once na-uploaded na yung firmware sa Arduino board natin, pwede na natin itong i-connect using male-to-male jumper wires sa SPI pins ng ATmega328P natin. But first, i-unplug muna natin yung Arduino sa computer para maiwasang masira yung board in case na magkamali tayo ng connection. So note lang, itong si digital pin 10 to pin 13 ang SPI pins ng Arduino board. So, digital pin is yung SSP ng Arduino board. I-connect natin ito sa pin 1 or yung reset pin ng chip or ATmega328P. Then, digital pin 11 is yung MOSI pin. I-connect naman natin ito sa MOSI pin ng ATmega natin, which is nasa pin 17. Next, yung digital pin 12 ni Arduino, which is yung MISO pin naman, i-connect naman natin ito doon sa pin 18 ng chip. And then, yung digital pin 13 ng Arduino, which is the SCK pin. I-connect din natin ito sa SCK pin ng ATmega328P, which is nasa pin 90 naman ng IC. And last, i-connect natin yung VCC ng Arduino to the positive line ng circuit and ground to ground. So now, i-plug na natin yung Arduino board sa computer using USB cable. Then, again, i-open ulit natin yung sketch. So, basic blink lang muna tayo. Ang purpose lang naman nito is matutunan nating mag-flash ng program sa standalone microcontroller using different methods. And after that, pwede na natin itong i-apply sa mga projects natin. But syempre, mas minimize na yung circuit and also less yung cost ng project. So, balik tayo dito sa tools. Select natin si Arduino/Genuino Uno. Then, yung COM port number ng board. And iset natin yung programmer na Arduino as ISP. So, pag USB ASP ang gamit nating programmer, naka-USB ASP din ito. Pag Arduino via SPI interface naman, iset natin siya sa Arduino as ISP. Then, click upload using programmer. So, wag kayong malilito. Pag mag-upload tayo directly sa board, so simply, upload lang. Pero pag gagamit tayo ng programmer board to flash code sa mga microcontrollers na target natin, upload using programmer ang gagamitin natin. Then, once na done uploading na siya, meaning working din yung method na to. So, okay na. Kung makikita nyo, nag-blink din yung LED. So, ang last method na ituturo ko is using a blank Arduino Uno to upload programs on a standalone ATmega328P via USB serial communication. So, doon sa dalawang naunang method natin, SPI interface ang ginamit natin. Dito naman, ipapakita ko yung way in case na USB serial communication ang gagamitin natin. So, dito, blank Arduino Uno board ang gagamitin. I mean yung Arduino Uno na walang microcontroller or ATmega328P na laman sa kanyang board. So, same circuit pa din kanina. Alisin lang natin yung previous Arduino Uno board na ginamit natin. So, ito yung pinakamadaling way sa lahat, but of course, kailangan mo ng Arduino Uno board na walang lamang microcontroller. So, simply, una i-connect lang natin yung reset pin ng Arduino board to the pin 1 o reset pin ng ATmega328P IC. And then, i-connect naman natin yung digital pin 0 or yung RX pin ng Arduino Uno board sa pin 2 ng chip, which is also yung RX pin din ng chip. Next, yung digital pin 1 naman ng Arduino Uno board, i-connect natin ito sa pin 3 ng chip. So, yung pin 3 naman is yung RX pin din ng ATmega328P. So, nakadirect lang siya. Reset to reset, RX to RX pin, TX to TX pin ng chip. And last, i-connect na natin yung VCC ng Arduino to the positive line ng circuit at ground doon naman sa negative line or ground din ng circuit natin sa breadboard. So, buo na yung connection natin. I-plug na natin yung Arduino board sa computer. Then, magbukas ulit tayo ng sketch. So again, para masubukan lang nating mag-upload, go to examples, basic, then blink. Then sa tools, select Arduino/Genuino Uno board. Then yung serial communication port number ng board. And then simply click upload. And hintayin natin hanggang mag-notify na ng done uploading. So now, nag-done uploading na siya. So meaning working itong method na to flash sketch sa ATmega328P IC standalone. So yan lang ang ilan sa mga methods or way to program this ATmega328P microcontroller. So malaking tulong na matutunan natin ito lalo na kung gagawa tayo ng mga maliliit na project using microcontrollers. Like example na lang, itong LED reactive face mask for this season. Or kaya naman, mga maliliit na robots, at iba pang mga project. So I'm Jeff Magsino, at I hope na may mga bago na naman tayong natutunan, at yun nga ay mai-apply natin ito sa mga projects na ating naiisip na gawin. So hanggang dito na lang muna, and thank you for watching this tutorial.